Okay. Hey guys, welcome to the masterclass, and we can start. So we can start with let's see who is present in the chat. If anyone can send plus messages, I'll know about them. Okay, am I audible? Okay, awesome. So yeah, so welcome to the masterclass, and today we will uh, learn about how to build smarter, sharper, and high-performing agents in which we are going to deep dive on something that will uh, deep dive on something that will separate the hobby agents or hobby projects from production ready AI agents through evaluation and hardening. By the end of the session, you will have a systematic framework for making your agents bulletproof or foolproof. So, yeah, uh, a bit about me, myself, Kush Patel. I'm founding engineer at Lyzr. Uh, I architect agents. I make the agents align with the user intent, and make them behave using the agent simulation engine. Today, I'll share uh, a methodology in which where you will learn how to build a agent and how to evaluate and how to harden the agent at scale. So let's start with the agenda. So we will go through the problem statement, the framework that is known as CRISP AM framework, our agent simulation engine, evaluation metrics, what evaluation metrics we need to look at while evaluating it, reinforcement hardening, and we will also see a live demo of the simulation engine tool. So um, let's do a reality check. When the agents are live, what happens? Uh, we don't know what users are coming. The inputs from the users can be messy. Uh, it can be confusing for the agent. The edge cases can, while developing the agent, the developer, the builder doesn't know what are the edge cases. So it starts from where like it works on my machine and it doesn't work on production. Um, we have also heard from Google that they launched their first LLM known as Bard, and we saw what happened when it gave bad responses. It does destroy the user trust user trust. So to overcome that, uh, yeah, we need a framework. So what is that framework? So CRISP AM is a framework that can cross industry standard process for agent management, a structured methodology which is built for developing, deploying, and managing agents. So that is a concept known as CRISP DM, which is in data mining. It starts from gathering uh, details about uh, business requirements from the user. So in that we ask the user for what purpose you want to build the system, and then we go through the whole process. So for agents also we need a approach that is what you have introduced known as crisp AM, and we will go through all the phrases. So the phrases start with intent framing, context design, agent design. Uh, then we build, test. The most important is the tuning and evaluation. Once we are confident with tuning and evaluation, we just scale it. So we will go through all the phases, all the four foundational phases one by one. So building a agent all starts with intent framing, where we need to define the outcomes, not just the requirements. We should know why we are building the agents. We should know for whom we are building the agents, who are the user, who are the stakeholders. We should define the scopes, and we need a success matrix for that. So a well-framed intent or problem statement that we are trying to tackle using the agent, it will solve a lot of problems when we are further building out the whole agent. Next phase is around about context design. So we need to, so how humans think is, without learning we cannot do task. So same goes with the agents. We need to give information to the agent for it to give some response. So your agent is only as good as the context you give it. So we need to figure out what rag we will give, like what rag strategy we will give it to them, what kind of memory the agent should have, the tools, the actions, what actions can the agent take in order to accomplish the task. So in order to get a good agent, we need to first come up with the data sources, the knowledge that we want to give, what actions it can give, what actions it can do, and what kind of memory strategy should it have. So this was the second phase of the framework. The third phase is designing the agent itself. So uh, in the previous workshops also we discussed about single agent, multi agents. What are the different architectures, manager agents? We saw role, goal, and uh, instruction. So when we design the agent, we need to get a certain behavior. A behavior we can give it via a role, and we need, and of course, to get a certain task accomplished, we need to give the goal. So all these we need to define in the system prompt. We need to give examples, and we need to give the formatting structure for that. What will be the escalation paths? We can also define the guardrails, which is present in the studio. So we can start simple, but like if we design the agent well, it will be able to do a lot of work for us. We will be able to automate the whole process. Now the next is, once the agent is like ready, we came up with something. We can deploy it and test it on our dev environment, as it is a baseline for us. On that, we need to do the the initial test for to get the performance, so we can give it to our stakeholders and get the response. We need to do the integrations on that. We need a, like, through the observability layer we can see how the agent is responding on what queries. So these are the four phases, and when this ends, the fifth phase is where we make it work really well. So that is the tuning and evaluation. Most of the teams, uh, they build the agent, they ship it, and ignore this phase, and where the agent fails in the production. So same happened with Google as well. Uh, when they released the Bard, uh, if this hard work would have uh, done, they would have really get a good LLM at the first. from the start itself. So in this phase is where the good agents that we build will become great. And of course, if you'll skip this phase, you will the agents will fail in the production, and at the end, the whole system, the company can fail. Uh, so this is the development life cycle or a flywheel where we we need to measure, analyze, improve, and validate the whole agent. And we need to do this until we meet all the targets and KPIs. Okay, we will come on the questions as well. Okay, this is on Lyzr itself. So we need to keep iterating until we get the correct behavior for from our agents for our stakeholders, and there is no shortcut for this. But there is a system that is built that can help you accomplish this. So yeah, coming back to the 6 phases, we will deep dive into uh, tuning and evaluation. Uh, so in this, we have built something known as agent simulation engine, which is a playground for stress testing agents before production. Yeah, where you can simulate real world users. Uh, you can measure different metrics, hallucination, task completion. Uh, you can iterate rapidly on the you can iterate rapidly, give feedbacks, identify issues, fix them, and it will be able to handle complex scenarios, edge cases that the agent can face in the real world. We'll also learn something known as reinforcement hardening, which is a new term introduced by us uh, along with the simulation engine. So let's do a deep dive on this. Uh, the simulation engine is built on the concept of JEPA world model. This is a research paper from Jan LeCun, as Jan LeCun is the most famous person in the AI world. This paper came early, a few months back, few years back, and what this paper is about: when we want our our system uh, ready for the real world, we need to simulate the whole world. We can call it as a world model where we have different actors that are uh, personas, where we can have different perceptions, where we can configure it, where we can introduce memories. We can have different metrics, what actions the agent will do, and for the scenario, how will it perform. The paper is at the paper is for fine tuning models in latent space, but we are uh, utilizing the cognitive architecture of world model. So this is the simulation engine's cognitive architecture, where we have like a multi-agent system working in order to improve your agent, in which uh, we have a agent that is being simulated. So it starts with a persona generator agent, which generate real users. For example, it what if there is a agent and like it has three kinds of users to start with: beginner, expert, and impatient. For each user, there can be different scenarios as well. Uh, for example, password reset or API help or error. And each domain can have different kind of scenarios. For the agent to test, we need the knowledge, not like what the agent should. So each agent will have some knowledge information with it, the information architecture that we talked earlier. So for using these three, persona generator, simulation, and knowledge base, we will try to generate test cases based that are grounded with our agent's information. And then based on the simulations, we that are also known as test cases. So simulations, we evaluate the agent against those simulations. We do the simulation in real time, and then a evaluator agent comes in and it evaluates, does it pass for this matrix: test, task completion, hallucination, answer relevancy. And once we have a comprehensive results, like if we are running 50 test cases, 10 test cases, 20 test cases, simulations, we'll have some results, pass or fail. And then a hardening agent comes in, which checks why the agent failed. It it takes the failed test cases, it loops back, and it improves the agent configuration. That is the agent design, the prompts. It adds guardrails if needed. It removes certain instructions that are redundant. So the whole system works together in a loop and tries to harden the agent. So this is the simple, this is the world model concept in the simulation engine, where different users come in with different perceptions of the scenarios. They have the knowledge about the agent, and agent goes under simulation in the real world, in the real world model, and uh, and evaluation happens, and it improves the it makes the agent ready for the world. So uh, okay, there are different evaluation metrics that we can look at to evaluate the agent. One is task completion. This is core evaluation for the agents. So task completion and hallucination. This is what the agent simulation currently have and we started with. And in in this we can in the task completion we can see, did the agent complete the assigned task, that is the instruction, did it follow the instruction. In hallucination we see, okay, the information that was given, did it give the information in a right way or not. Then we have tool related matrix, that is for the actions that the agent can take. So did the agent select the right tool? For example, if we are sending an email and the agent has like it's a general agent and it has email sender, email tool, a Notion tool, it should not pick the Notion tool. It should only uh, pick the email tool to send the emails. So in this tool, like tool metrics, we can see if if the agent if the agent did select the right tool or not. And in order, after calling the tool, did it give the right arguments or not. And the same happens for knowledge module. The information that we gave, did it use the information in the right way? Is the knowledge present in the answer? How relevant in the answer. And yeah, we already talked about knowledge retention. Is the answer present in the, like, is the information present in the answer, or it just hallucinated? So yeah, okay, let's do a live test of the simulation engine, where I'll show you how the simulation engine works. Uh, okay, let me check if you can see the correct page. Okay, let's. mm, in this, we will test the agent known as exit process agent, where agent like when when an employee resigns, the agent takes the exit interviews. And yeah, this is a very small agent. It has a very small instruction, goal, and agent role. So we will try to like create a world model for this. Currently, our simulation engine is in the preview mode for close testing, and whoever is interested, like we can open the simulation engine for them. So this is how it looks. Here we need to come and select the agent, where we can create an environment. We can name the environment anything, and once we go in the environment, it auto populates some of the scenarios, possible scenarios and possible personas, and it also looks into the knowledge that you gave in drag. So this is how a world model looks like, where we have the agent, we have the scenarios, personas. Let's look at some scenarios. For example, if the exit process interview is there, in this, the agent asks the user to do okay knowledge transfer session before the exit happens. Then the user needs to do some documentation. Then feedback happens. And what are the personas? So if it is a new employee and that needs that just if there is a HR who is interacting with the agent, or IT support who is interacting with the agent. And here we can add our own custom scenario as well. Uh, we can see like, yeah, we can pick any scenario and add it. In the same way, we can also add any persona. And for like once we have a set of scenarios and personas, what we can do is we can generate the simulations. So we provide the user to generate the simulation uh, that can be used for evaluating the agents. So let us generate. We can generate for all the scenarios and personas, but we will end up with hundreds of test cases. So for the demo purpose, we will just test for test for small number of cases, and we can also add our own. Sorry, yeah, we can also add our own custom simulation. So if the company already have some data set, they can upload their data set by giving the some simulation name, user input, and expected output. Uh, yeah. Okay. Okay. We can go to another one because for some reason I clicked that. Okay. So this was already created, and we have some evaluations present in it. What we will do is we will select them. We will configure the evaluation where we have like ability to select different metrics, starting with task completion, hallucination. These are the most required ones, default ones. We also have tool modules, metrics, and knowledge-based metrics. This get enabled when our agent already have a tool attached to it. For example, this is a SDR agent, and if it has some knowledge base, uh, and if it has a tool attached, let's try a demo tool. We can see that okay, knowledge base is there. Configure. We can see that the metrics are like evaluation metrics are available. So we can evaluate on the basis of this. Coming back to our exit interview, uh, exit process agent. Okay, let's select, configure, and run the evaluation. So right now, what we are doing is in real time, we are picking those simulations and uh, e- uh, picking those simulations and like running them, simulating the agent on them, and then we are also evaluating that. So once all the yeah, we can see that. Okay, we can see the detailed report as well. Uh, so what we can see here. So this was the input. This was the expected output that in the simulation that we generated, and this is the agent response. So we have a reasoning also here why the evaluation is correct and why it gave the score as 80 and hallucination as 0. We also have one failed one. Let's see that. Okay. So for this user input, this is the agent response that it gave, and it has also identified some issues. So it did not proactively schedule the interview, and it did not propose the exact date and times. It did not send any. So it tries to give like it tries to identify the issue, and it also provide what are the suggested fixes, and it looks at the execution trace that happened. So once we have this, there are two modes available. One is manual harden, and second is automated hardening. So in manual harden, you can just see the configuration, the hardened configuration for the agent. And so, okay, let's see this. It got generated. This was the goal and instruction. I think so. The screen sharing stopped. I'll try to share again. Okay, yeah, I think so. It is working now. Uh, in this, we saw the we saw how the naive the agent was. It was not ready, but This is the improved instruction based on this failed test case. We also see what new goal we can give it to the agent. We can so we detailed all the instruction in like in a best like in prompting. There are best practices. How should we prompt our agent as well? So it tries to use all caps. It tries to give in points, and yeah, it is using our internal tool. What the internal tool is? So we have an internal tool known as improve prompt, and it tries to improve the prompt. So this is based. This is also based on like couple of research papers, and we came up with our own as well. So coming back to our SDR, uh, exit process agent, and we okay, we may need to select this. Come here. Okay, we don't have that. We can generate the hardening configuration again. Yeah. So now, if we are good with the current prompt, and if we want to do some new updates in this update, we can come here, edit the prompt, and we can push it to production if needed. And what happens when it goes to production is your current agent, uh, exit process agent, is now updated with the new prompt. So it is already hardened for the real world scenarios. So let's roll back to the previous version because we are going to start an automated hardening process. Yeah, we have rolled back our agent. Uh, so we can so the simulation engine is made of a multi-agent system, and how each agent of a simulation engine looks like. We already saw persona generator, scenario, simulation generator. In order to generate a simulation, we get the scenario, we get the persona, we get the knowledge from the documents. So we can create grounded simulations, and we generate the simulation. In the same way, we get the failed evals. We see the list of issues, fixes, uh, what all are the failure cases, and it analyzes and gives a hardened configuration. So it comprises this uh, of this agents. Uh, yeah. So we already discussed this. We can come back to this once our agent service is live. Let me share that again. The simulation engine is live again. Uh, so coming back to the SDR exit agent, we already ran this test cases where we saw one got failed, and let's start the automated hardening. So in automated hardening, we can define how much number of loops it should take. So for each loop, it generates a configuration and it tries to evaluate for all the cases again. That is what we are seeing. Okay, so it started running, and okay, and what we saw is from the first run, this test case got failed, and in the second loop itself, we get all of them is passed. So how did it do it? It did the improvements in the configuration in the instruction, and it did improvements in the goal. So we can see the detailed report here as well. Which test case basic. So the knowledge transfer, and it got passed with a reasoning as well. Why did it pass this time? So in this is how we configured the agent hardening, uh, automated agent hardening, and we can define the number of loops that it can have. We can also have more and more loops until we get our best case for the agent. And yeah, okay. Coming back to the slides. So we already know it is a process to like iteratively strengthen the agent in a simulated environment. So we calibrate the prompt, we tune the prompt. If required, we can update the prompt. It suggests everything. So yeah, uh, the playbook is simple. To evaluate any agent, we need to define the simulation. So in order to get the behavior of the agent right for in our crisp AM framework, uh, this is the most important part. We need to have the simulations right. Lyzr helps to get those simulations. Uh, then then in the loop, we run them, we measure them, we identify, and we iterate and improve. As simple as that. And we just saw that right now. It tried to pass, like we got all greens. That is, we saw the improvement in the agent. And from a case study we did internally across different benchmarks, we saw that before the success rate was 47%, and now it came to 94%. And yeah, so this was the whole crisp AM, like quick reference with all the phases. Once you have your agent tuned, where it is ready to like ready for the real world, we can like deploy it at Lyzr. We have the infrastructure is ready for as it is an infrastructure platform, that we have the infra to deploy it at scale. And yeah, based on the user feedback, then again we can come back, evaluate it, and scale it. Okay, for the developers, I have something that is we are what I have is, let me share. For example, uh, so what we tested right now was an agent imported from external framework, and we can import a external framework inside simulation engine, and we can evaluate it, and we can migrate that imported agent back to the external framework. For example, we can export it to LangGraph, Creo AI, Google ADK, and AgentKit. Let's see, like if you want to export it to AgentKit, we can download it. Once we uh, once we download it, you will have a Python file through which you can play around and do your changes. But at the end, you will get a agent that is ready for business world, ready for real world. So how can you import a agent? You can come to import here. You can upload a file. I'll pick the file that we just exported. So yeah. So once we import it, it tries to it tries to convert that to a Lyzr agent, and in this way we can see the external agent. And once we have this, uh, it's on us if we want to add the memory or not. And if it has some knowledge base, we need to create a knowledge base on Lyzr and attach it to here. and we can create again the same agent. Uh, there is one more way to import is we can import it via A to A. If your agent is hosted in your environment, you can expose it via A to A, and you can do your evaluation test. But in this, you can just when you have a to A agent, you can just do the evaluation. You cannot do the hardening because we do not have the access to the prompts. So yeah, based on this, you can, for example, if this was the agent, this was a simple echo agent that was built to test the whole system, uh, where yeah, you can evaluate like you can evaluate your agent here, and you cannot export it because we do not have access to that. And if you have any Lyzr agent, you can do everything that you want with this with the simulation engine. So yeah, I have okay. Okay. We are also launching a SDK for this, where the users can. Uh, okay, I'll show the SDK as well. I'll share the screen again. Okay. Okay. This is the SDK for the simulation engine where uh, my screen will be visible in short time. So yeah, in this SDK, you can do the whole process that we did on platform via code. So for the devs, you don't need to go to like you don't need to go to visual stuff and do it. You can do the whole evaluation at code level also. So you can simply install the SDK. We will release it on PyPy as well soon. You can pick the API key from the studio, get your agent ID, and test it. Soon this will also have support for external agents like LangGraph, CreoAI, strands from AWS. So yeah, OpenAI will be supported as well here. Mm, yes, if you guys see any bugs, you can report it. A website, Twitter, LinkedIn is available, and give a star to the repository. Mm, yeah. Coming back to the slides, where do we have? Okay, and yeah, we already saw the quick reference. What are the key takeaways? You can read them, and we can do a Q&A session if you guys have any questions. So yeah, you guys waiting for the questions. And if you need the beta access to the simulation engine, you can fill out the form. and please join our Discord channel as well for any other questions. Okay, so yeah, thank you for joining, and yeah, thanks a lot. Have a nice day. We can conclude the session if you guys don't have any questions.